Everyone, welcome to the channel once again. In this video we'll learn about linked list. Now linked list is also a type of data structure in which it is saved as node wise. Now this would be considered as node, this would be considered as a second node, and this would be third, and this would be fourth. Now this is the first, in which the first part contains the data and the second part contains the address of the next node. Now here also this is the data, this is a pointer which will save the address of the next node. So something like that, singly linked list is saved. There could be a doubly linked list also. Now this could be a node in which in the first node it will be null, and this will save the address of the next node. Now if this is the node, here this would save the address of the previous node, and this would save the address of the next node, and this would be saving the data. If you go to this node, what you will do, this is the central part is saving the data, the right hand side would save the address of the next node, and the left hand side would save the address of the previous node. So something like that is a data structure linked list. So in linked list you cannot access randomly, you cannot access through index. You have to first get the first node, and then only you have to iterate through and reach to a particular node which matches the data. So something like you have to iterate every time to reach to a particular node. So this is the linked list. Now the operations which can be performed again: add, insert, access, delete, or search. Now adding or inserting in the linked list is very easy. If you are inserting any item to the first position, what we will do, before this node, if you want to insert, what you will do, you will create the node, and then you will address bar of that node, you will put the address of the next node, that would be this, and the data. So it is very easy to create at the first node. Now similarly, if you want to insert any node to the last, it's very easy. In the last node, you have to insert the address of the newly created node. So it will be easy. If you want to insert in between, like suppose if you want to insert between these two nodes, 3 and 5, then you have to iterate here, and then you have to create node, and then here in this node you have to put the address of the newly created node, and in the newly created node you have to put the address of this node, like fifth one. So this way you can create the node. This is for singly, and similarly to the doubly linked list. If you create a node here, then you have to change the previous address and the next address correspondingly. Like if you create here in this position, like in the right side of this 8, you have to put the address of the newly created node, and in the left of the newly created node you have to insert the address of this 8, and in the right of the newly created node you have to put the address of this node which is containing the data 4, and here the left hand side of this node you will put the address of the newly created node. So something like that you will do to insert the node in an linked list. Now how you will add, access, delete. Now in most of the languages like C# and Java, you will find inbuilt libraries. You can directly import the library and use the linked list feature. In this demo we'll perform a demo in which we'll create our own linked list, and then we'll perform some operations, and then we'll later see how we can use the inbuilt features of C or Java. So let's go to the lab. So this is the JDoodle. Now you see I have created this class node which has this data and the node of the next node. Now this is a singly linked list. If you want to create a doubly linked list, you will create a node which will point to the previous one. So you can write like something like this, node and previous. So and then you will save the data correspondingly. In this demo I will be showing in the singly linked list. Now what is class? Class is a user defined data type. So I am creating a linked list data type in which this variable will save the data, and this variable will save the address of the next node. Now this is the class I have defined, data structure I have defined. Now this is the linked list demo. I have declared variables like head, and then I have created one method which is add. So if the linked list is empty, you have to create this, like if I check null and then this dot head, the data we will put. But if the linked list already have data, it's not empty, then you have to iterate and find the next node. So I have to find the node to add, and then next I'll put the address of that previous node and this. So how I'll use it, I'll create a main and I'll create the object of this class which I have created. And then I am adding two data, 104 and 108. It will print the data to the console, mylist.head.data. Mylist, like, it will put the first item and the next data item, and it should print both. You see 185 and 10. Now Java, you have this linked list class. Similarly in the .NET also, in C# also, there is a class of linked list which you can use, and this will manage internally the address and the data part. Now I have created one object of this alphabet list, linked list. Now you see in this I am adding B as the one item. So what it will do, it will add B, and then when it will go to this line, it will add A before B, and then it will add D because it's last, and then I'm adding at the second position. So it is already last, so it will move the D to the next node, and at the second it will add this C. So let's see, I'll run this. Now you see A, B, C, D. It's printing A, B, C, D. A is the first item, B is the next, C is the second item, and D is the last. You see, so this is this one. Now this second is actually starting from 0. It is the third item, but it's starting from 0, that's why it's counting as a second. Now if I want to access any item, like suppose if I want to get the second item, I have added it C. So how I can just alphabet dot get, and the second position if I wanted to get, you can get it. So you see illegally start expression. Okay, so I have not done this, so I'll do it. You see, this is my list A, B, C, D, and the C is the position second. How? 0, 1 and 2. So at the second position it is there. Now if I want to get this first item, from my list, how I'll get this. If I execute it, you see the first item A is there, A, B, C, D. Now the first item method is printing from this. Correct. Now if I want to search, like suppose I am searching in this linked list, B is present or not. So I am searching contains. When I'll run this, you see it's printing true. Yes, B is there. If I want to remove item, I can check. I can remove also. Now if I remove the first item, so currently A, B, C, D is there. If I remove A, then B, C, D should be printed. If I'll execute, you see, if I'll execute and I have to print also so that you get it. Now you see A, B, C, D is my linked list which is getting printed here, A, B, C, D, and then I am removing the first item and then again printing. So A, B, C, D, and then it's printing B. Correct. Now if I want to remove the last, so when I'll run this, you see A, B, C, D is there and the last item D is deleted, so it's removed. So last item is removed. So this is this, and now I can remove it through data also. Now suppose I want to remove C only. So if we run, you see A, B, C, D is there. I have to print also. So if I am printing this, you see A, B, C, D is the data which is created earlier, just created in the beginning of the program, and then I have removed this C. So A, B, D, C is removed. Correct. Now if I want to remove the first node, I'd remove at the 0th position node. So which A would be removed, B, C, D should be printed. Now you see A is removed and B, C, D should be printed. So this is the action you can perform through get first, contains, remove first, remove last, remove at a particular node. So this way you can perform similar methods and similar operations are there in other languages like C# also. You can look into it. If you are using C#, you need not to worry about that. Now in JavaScript it is not there, like this linked list feature is not there. So if you are using JavaScript, you have to make your own class for that. Now if we go to the big O notation, now access, if you are accessing the first item, you can access it in constant time, because this is the first item and you will start from the first item, so it will be constant time. Now if you want to access any other item, because you cannot access this randomly, so you have to iterate through, like you cannot access this node directly because there is no index, so you have to go first here and then here, then here. So searching is always a linear time in linked list. So linear time. Again, update, if you want to update, you have to iterate through that element, so that would be also linear time, because you have to iterate through that. If you want to insert, now if order does not matter, at any position you want to insert, so it would be constant time, because if you want to insert here, you have to put this address in that and the newly created node address of this node. So in any place the same activity you need to do. So for that it would be a constant time. So if order does not matter, it will be constant time, but if you want to last item, then you have to iterate through it and then only you can insert, because you cannot directly go to the last position without iterating, because you don't have the index. So you have to iterate and reach to the last position and then you can insert it. Similarly, searching is also a linear, because you have to iterate through it and then reach to a particular position, similar to a deletion, because once you will search it and then only you will delete it. So this should also be a linear time. Now if you want to short the linked list, the recommended way would be merge sort. Again, because random access is very slow in linked list compared to arrays, because you see arrays can be randomly accessed through its index. So merge sort is the recommended sorting if you are dealing with the linked list, and quick sort and heap sort are not preferred, obviously, because of the not good performance in random access. So this is all in linked list. If you have any queries in linked list, you can put it in the comments below, and if you are liking the videos, please do subscribe to the channel. In the next video we'll see stack and queues. That's all. Thank you.